no problem.
Okay, can you now share your screen, your presentation?
Yes, let's share my screen. Application window. Can you see my slides?
Yeah. Can you now, yes, turn on slideshow?
Yes, sure.
Yeah,
Okay.
great. So
Yes.
we're starting our talks for the second day of our school, and it's my great pleasure to introduce Zhou Yu, Dr. Zhou Yu. She's assistant professor at the Department of Computer Science of University of California in Davis, and she's doing research on intelligent interactive systems. And today, Zhu will give her talk on this topic for us. So let's welcome Dr. Zhu.
Great, thank you. Please do let me know if you can't hear me clearly. I can increase my volume or whatever I do to speak louder.
Oh, everything is okay. It's very nice and good, and sound is clear.
Sure. I'm also going to play some videos. Do let me know if you can't hear the videos. Okay, I'll try to see if I can do anything to help.
Certainly.
Sure. So today I'm going to talk about majorly my previous thesis work and my continuation of my future work. So I just finished my PhD in Carnegie Mellon University and started my first job in UC Davis as assistant professor. So throughout my entire research career, I worked on conversational systems. So today I'm going to talk about like a new concept that I'm raising in my thesis called situated intelligent interactive systems. First of all, I would say a lot of great research is inspired by science fiction. So mine as well. So there's a movie in 2013 called Her. It's a movie about a conversational system that talks to the user for this guy and helps him in a lot of things in his schedule and later on. So even build up a relationship with this person. So the conversational system is named Samantha. So Samantha is what we think an ideal conversation system should be, to make the user feel everything is at ease, very easy to interact, and very helpful in completing all the tasks. It is, in another word, you take no extra cognitive load to talk to Samantha compared to talk to another personal assistant that is another person. So here is a little clip of showing what Samantha is capable of doing, why she is doing so well. So it's only a little clip. I will explain why it is a perfect example.
Morning, Theodore. Morning. You have a meeting in 5 minutes. You want to try getting out of bed?
You're too funny.
Okay, good. I'm funny.
So here we see that Samantha is able to detect that the user is actually still in bed after she's telling him that you should get out of bed. So this requires situation intelligence. Basically, Samantha is able to use multiple channels of information, for example, the vision, knowing that he's still in bed. And then she's able to detect that she has a goal that is waking the user up, but the user is not doing exactly what she told him. So she took a strategy, what we would usually call error handling strategy, basically what we should do to handle the error that the user is not performing the task. So Samantha basically tried to use a interesting conversational strategy to manipulate the pitch, basically the voice, to generate an interesting utterance saying, do you want to try get out of bed? So the lengthening of try really makes it a really interesting and funny conversational vocal experience for the user. So the user is really happy and eventually gets out of the bed. So here what we think is really important is the situation intelligence that the system is able to detect and possess. So basically, the system is able to be aware of the situation that he is positioned. Basically, here the user is the most important part of the situation. So the system is able to detect what the user wants and what the user's current state is, and trying to cooperate with the user to complete certain tasks. So here is another example of our old friend Siri. So what we currently could access, most of the people can access to conversational systems, and Siri is one of the example of the earlier example. And usually we're still regarded as the current state of the art for the industrial designed conversational systems. Let's just watch a little clip to see the comparison of Samantha, the perfect fiction story conversational system, and Siri, which is what we have now. Siri, can you recommend me some restaurants in the Seattle area?
The best rated option I found is the Cheesecake Factory. Is that the one you're looking for?
How expensive is that restaurant?
Does that one sound good?
You didn't answer my question.
If you say so.
So what we can see here is some errors that happened along the way. I asked specifically, can you tell me more about that restaurant? So that is basically saying the restaurant that we referred previously. So Siri is not able to do the co-reference. He is not able to be situationally aware of what we have been talked about and what I'm trying to get to. So we can see that this fair comparison, we hear a lot of complaints with current conversational systems. For example, bad at understanding me, bad at remembering things, bad at being coherent, but being interesting, bad at providing variety, basically just telling you the same thing over and over again, bad at being natural, just didn't do anything. So we hear a lot of user complaints here. My research basically is trying to use the framework that we just proposed, the situation intelligent framework, to address these complaints to a certain degree. So here, let's see, a lot of times when we are designing conversational systems, we say that we want the system to be natural, to be effective, just like the human. So we would start our research by looking at how humans converse with one another and how this natural fluidity flows, so we can learn something from them and build that into the conversational systems. So here is a conversation about two people socially talking about whatever topic they wanted to talk about. So here they're talking about Welsh cooking. So I'm going to play this clip, and what we are going to do here is trying to look closely what kind of interaction they are having that is facilitating this fluid conversation.
Welsh cooking then.
Welsh cooking.
What do you know about Welsh cooking?
I've eaten my share of Welsh cakes, and I actually have to say I like the Greg's ones better than the traditional. I like the cinnamon taste. I know that's not traditional.
Maybe you might want to try the other ones in Sainsbury's and the ones next to the blue ones, because they're quite cinnamony.
Yeah.
I like and they put sugar on as well, which I don't know.
When we went to the castle, we had this cawl, like this stew. Yeah, cawl. Yeah, okay, right. Yes. That was
Welsh stew.
Yeah, well, that was quite nice. Actually, yeah, it was very well cooked and lots of nice lamb in it.
So if you look closely, we see a lot of strategies that the one user is actually using to help the conversation flowing. For example, this P1 is saying Welsh cooking then. What do you know about Welsh cooking? So he's in a positive position using an active participation strategy to engage the other user in the conversation by asking a question. What do you know about Welsh cooking? And another one we see is called grounding. So what we call grounding is a very common concept in conversation study, basically saying we're trying to make sure that the conversational partner, basically the other person, is actually knowing exactly what you are talking about. Are you on the same mutual ground? Are you on the same page about an understanding of a vocabulary, a concept, or whatever? So here, we know that the P1 and P2 here, participant 1 and 2, are actually trying to understand what exactly is called. So this is basically a Welsh stool. So this guy is very actively asking, are you talking about the Welsh stool? Because the other person has their mispronunciation at first. So after this kind of a communication, they're on the same ground. So they're grounded, what we call them, so that it can proceed to other things in the conversation. So they have a mutual understanding. So basically, we see that humans actually use all these interesting strategies to make sure that the conversation is fluid and natural. So what we want to do is to see exactly what the conversational system should do to imitate this, or to into a certain degree, so that when the user is talking to the system, we feel the same way as talking to another human. So we propose this framework called a situation intelligence framework. It has 3 components to it. The first component is what we call being aware of the situation, situational awareness. So here the situation can be anything, can be people in the environment, it can be the time, for example, the history of the conversation, or it can be the physical environment. Is it a noisy conversation scenario, for example, on the road, or is it an indoor conversation? All these aspects of situation are something the system would care for different tasks. For example, in a social conversation is what we think as everyday talk. User engagement is very important because what we say here, the engagement, is basically we can define it as the interest to continue the conversation. So if the other person is not able to be able to engage, to be able to feel interested in talking to the other person, then basically the social conversation is not going anywhere. So here, basically, we say that when you have a goal to reach, so what you first want to do is to look around to be aware of the situation that you are in. And then basically you wanted to design conversational strategies to help you to get to the goal. So here for the conversational systems, the strategies are actions that react to the situation. For example, what the previous user did is, for example, the active participation strategy to improve user engagement. So the user, for example, the previous one said, what do you know about Welsh cooking? So this is an active strategy to improve the other person's involvement and the interest to continue the conversation. So here the cartoon shows that these conversation strategies, what we think are puzzle pieces that could help you to bridge to the goal. So finally, so basically you have these puzzle pieces and you have the goal in mind and you're aware of the situation, then you need a plan to assemble your conversational strategies in a most efficient and natural way to bridge you to the goal. So that's why we need a policy. So this policy here is basically what we think in the conversation is to choose among the strategies that we designed previously in the second step, considering the situation that we are being able to aware in the first step to optimize towards a long-term natural interaction. So there are different things, aspects of the conversation you can optimize towards. So usually we think about like how efficient we get to the goal, how natural we get to the goal are important. For example, like our engagement. So maybe we say that our goal for social conversation is basically to keep the other people in the conversation. That's our goal. That we need to know when to select certain strategies so that the user don't feel that it's repetitive and and too restricted. So that's why we need a reinforcement learning policy. So basically to optimize towards the goal, to use a limited conversational strategies to make the conversation last longer, sounds more natural, more engaging. Here we're going to explain a little bit more about each step, what we should do, and what are the difficulties we see in them. So the first step that we see is called situational awareness. So we already said about like a situation could be anything. And one example is engagement in social conversation. So why it is very, for example, why it is very challenging to make the system aware of the situation. So first of all, what are the aspects of situation you care about? There are so many information flowing in different channels, the vision channel, the acoustic channel, the haptic channels. All these channels, what are the things that you need to take into consideration to track and reason and see throughout the conversation? So what we hear is, so we propose that we should use the task domain knowledge to select critical aspects of situation that will benefit the interaction most. For example, in social conversation, we think that engagement is most important because without losing the interest means the end of the conversation. So we basically say that we should be able, we wanted to track engagement. And then the second problem raises engagement is a very interesting. So what should we do to approximate that? So now it comes out a lot of literature, multimodal, different channels of information. Basically, here is what we usually call multimodal information to help approximate engagement. So, for example, you can use vision information. Are you smiling or not? You could use acoustic information. Are you speaking a louder voice or a lower voice? So all these information combine to approximate engagement. So here is an example. You can find different things and different conversations that are important and try to use different automatic obtained information from different channels to approximate them. After we are being able to aware of the situation, then we need to design conversation strategies to regulate this specific aspect of situation that you think is important. For example, we say that if somebody loses engagement in social conversational system, we need to do something. So for example, we could do active participation strategy. We could engage the user in this way. So the difficulty here is how do we design these natural and effective actions to facilitate communication? So mostly we would go through the conversational theories to look at what humans usually do, and we can design these conversation strategies automatically in the conversational system to help to do that. So how do we design these conversational systems strategies? This comes in that we could use natural language processing skills and also other knowledge-based information to help us to design these strategies. Finally, after we have the strategies to deal with the situation that is going out of the hand, we need to know when to use what strategies to deal with the situation. Basically, we say that if the conversation is a chain of reactions, everything depends on what happened previously. So you want to optimize a chain of actions, a sequence of actions. So reinforcement learning is basically to say that we want to optimize these by leveraging all the theories and learning methods. Here is one of the demos that we have built in my PhD work. So basically, this is conversational system talking to a human that is shown on the screen. They are performing a task, which is a social conversational system. Basically, they're talking about everyday social topics. So what we want to do in the conversational system is we're trying to detect users' engagement using multimodal information. And whenever the user is losing the engagement, we would do something, use our conversational strategy that is pre-planned to help the user get back to the conversation. Now let's play the clip. Sorry, let me adjust the presentation a bit to see why this guy is not playing. Give me a minute. I'll find the clip again on my local computer and play it.
Yeah, okay.
Sure. Sorry about that. My PowerPoint problem. Okay, let's see. Can you see the big screen here?
Yes.
Okay, let's try this. So this is the conversation system talking to another user. We're trying to detect the user's engagement all the way along, trying to be able to use conversational strategy to improve users' engagement along the way.
How are you doing?
I'm fine. How are you? Any thoughts?
Any thoughts?
So here we detect that the user is losing the engagement based on the multimodal information.
Let me see. Do you want to go to my friends?
So we use the initiation strategy.
No, I have a lot of work. Can't go.
Enrique.
So here we basically is trying to make the conversation to do exactly what conversational system to do what exactly the human do. Okay, let's back to this guy. What we hear so far, we used the example of social conversational systems, but that was not the only thing that we care about in conversational systems. The conversational systems all the conversational systems have different uses. It can be applied in various areas. For example, like entertainment, education, and healthcare. For one thing that we did before is for entertainment, we created a targeted advertisement conversational system, basically recommending movies to people. For education, we did something which is a collaboration work with ETS, which is a conversational training system that helps people to train for job interviews. Of course, these systems could be used for other things like online education. So healthcare-wise, we could provide therapy for depression, like aphasia and dementia. We did a collaboration with USC, Southern California, on conversation on depression. So one more thing to mention is that conversational systems are not merely virtual systems, like for example, like building characters for games, video games. However, it could be also with physical embodiments, like service robots. You can give we have a work on direction giving. So basically, a robot use language to help you to give and gestures to give you directions. It could be also extended to other things like nursing and rescuing. So my talk here, let's go back to the outline a little bit. So we're going to talk about a specific task, specific example of our system called social conversational system. We're going to go through the 3 steps in details about the mechanism or how we're going to build this conversational system adhering to the situation intelligence framework. And then we're going to talk about other task-oriented systems like movie promotion and job interview training by extending the previous concept. And finally, we're going to talk a little bit about the robotic application. So back to the theme that we talked about, like a situational awareness. So one aspect of situational awareness that we've talked a lot about is called engagement. So here, the formal definition that we gave is the interest to continue to contribute to the conversation. It is the foremost, most important aspect of conversation, because that without the interest to continue, you can't continue, the conversation will be ended, and there's nothing that can be exchanged through the after that. So for any conversation, if you don't have the engagement with the other person, the other conversational partner, you can't get any information through or get any task, anything done. So in general, engagement is universally important in conversation. Here we just use one scenario, social conversation, as an example, because the social conversation doesn't really have a specific task to information that you have to convey. The idea is just to keep going, to continue the conversation with the other party. So so in this scenario, we can isolate certain task-specific information, knowledge that would be imposing on the difficulty of building systems. So first of all, how do we detect engagement? So we talk about we're going to leverage multimodal information. So here, multimodal means information from different incoming sources. Here we use 3 types of incoming sources. Verbal, which is, so basically you say something, the ASR, basically it's an automatic speech recognizer, which translate your speech into text. Then you can do all different kinds of statistic over it. For example, you can count how many words the user say. So normally, the more you say, the more engaged you are. Turn length, how long it takes you to finish your turn. Here, turn means that I say something, you say something. Throughout what I say before you take over, it's a turn. So the longer you talk in a turn, the more engaged you are. Time to respond. So how long it takes you to respond to the other person or the system. So usually, the quicker you respond, the more engaged you are. So second, so here we didn't really use the lexical information or semantic information. The reason mostly is we want the engagement predictor to be universal. So it doesn't have to be task specific based on the language, the deep meaning of the language. The other modality here is called visual modality. Basically, you have a camera on the conversational system. Then you can run different kind of automatic tracker and recognizer on it. For example, we used OpenFace developed by Louis Philippe Morency's group in CMU. So during your real-time tracker, so you could basically get the head pose of the user. Are you looking directly at me, or are you tilting your head? Action units here means that basically you have all these muscles on your face. So some of the muscle, we can detect the muscle groups and knowing that which direction the muscle group is moving. So we can use these action units to approximate certain nonverbal behaviors that are important to our conversation. For example, smiles. Most likely, if you smile, you're engaged in the conversation. Frowns, basically, we have the 2 action units that is close to your brow. If you're frowning your brows, mostly is thinking of that it's not that engaging. The other information is about gaze direction. Are you looking directly at me, or are you like looking within a certain angle? If you're looking directly and being focused with this, that's what we think are good gaze pattern for engagement. Then acoustic. Acoustic is what we think that is beyond something that is beyond speech. So basically, we can detect how loud you speak, how low you speak. Usually, people engage would change from speaking loudly to speaking quietly, basically more fluctuation in the power of the speech. Pitch is about how high you speak and how low you speak. Basically, we can manipulate our pitch. And if you're excited, your pitch change is much more likely to happen. So we're going to use all these informations that we can automatically obtain to help us to detect engagement. So what we want to do is, first of all, we're going to make it as a supervised training setting. So we collect our data with their base form conversational system, which is social chatbots, that doesn't have anything that was to do with engagement. So we had several interactions collected, and we annotated, we are asking the expert to say that if this user is engaged at this conversational exchange or the next conversational exchange. So the conversational exchange here, which is the annotation unit, means that if I say something, the system says something back. This constitutes as a conversational exchange. Basically, it has one user turn, one system turn. So we are able to see that if we collapse the scale into 2-point scales, basically we are asking the expert for this conversational exchange, is the user in the video engaged or not engaged? We're able to reach a pretty high agreement. So now, basically we have the annotations and we have the pre-collected data. We could use machine learning skills to train a supervised classifier. So here, because we don't have a lot of data, we have a couple hundred conversational exchange. So we simply just use our early fusion and under SVM with RBF kernel is able to do a pretty okay performance. So here, what we want to show you a bit in this slide is how each conversational each multimodal channel information is going to help us in predicting engagement. So we can see we have the baseline, which is a majority vote. Basically, everybody is engaged. What are the percentage? So basically, these are basic stats. And then the verbal, the red one, means that if we only use the verbal-based information, how much precision and F1 measure could we get? So here, F1 measure just means that the higher it is, the better it is. It is a weighted score of the precision and recall. Usually, like above 0.8 means that it's pretty reliable. So here, the green one is a visual information predictor. Basically, we only use visual information like head orientation, gaze information. The purple one means acoustic. We only use the power and pitch and other acoustic signals. And the light blue one means what means the feature selection means that we're going to use a stepwise regression to select the most to select a set of features from all the three previous modalities, so that we are selecting the information that are that will be complementary to each other, and also making sure that some of the noisy information would not be selected. For example, the purple one, the acoustic one, we can see that sometimes it is performing even less than the majority vote, because sometimes we have room noise, which would bias the feature selection here. So, would bias the the acoustic features, so which actually would not help if you add some of the information inside of the final predictor. So the blue one, the light blue one, the feature selection is basically selecting the information, the feature that are being able to complement each other in information, and making sure that we're not selecting the one that has noise, feature that has noise in it. So there are other things that we do a lot in combining different multimodal informations in models. So here we are only giving you a taste of why different information could be useful in conversational systems in detecting users' situation. The second one is, after we are being able to detect user engagement, what we're going to do if the user is not engaged. So before we dive into the conversational strategies, we want to give you an outline of what we have done so far to generate the responses. So for a social conversational system, there are two very popular methods that we usually use in generating the system's response. Basically, the first one is called keyword retrieval. So based on what the users say, that we extract the keywords of the user's utterance, and then we're trying to search these keywords in a database. The database usually in this is organized as one user term and the other user term. So it's two pair parts. So we wanted to find in the first pair parts, basically the question. Usually people say that what is the most similar first question that we have in the conversation in our database, and then we return the corresponding response of that sentence back to the user. So here we used both of the methods. So in the database, we used CNN interview transcripts and other Mechanical Turk collected human responses. Another method is skip-out neural network model. Basically, it's a typical neural net model. You can do, basically you want to do encoder and decoder. So we trained it on open subtitle. So each of the methods has its pros and cons. For example, keyword retrieval. If the user's response is very similar to the ones that you have in your database, basically you would come up with a really good response. However, if there's something, user says something that is totally out of the domain of your corpus, you basically can't return anything meaningful. So while skip-out neural network, just like all the other neural network, it also has problems. Basically, it adheres to this kind of language model instinct that is usually basically trying to generate things that is most likely to seen in a corpus. So a lot of times it would be a really simple sentence that doesn't have a lot of interesting point. For example, I don't know, I don't think so, because these happen the most and most frequently in the corpus. However, it doesn't really help the conversation going forward. So we can see that these errors basically, the system that we are using as a base system is basically choosing between these two generated methods. However, these errors would basically reduce the engagement of the reduce the engagement of the user. How can we avoid being able to producing these errors? Or how can we help if these errors happen? How can we bring the user's engagement back? That requires our conversational system to have these strategies. So we're here introducing 3 types of strategies that we designed so far. So the first one is active participation strategy, just like what we have seen how people did it. So according to the definition, the active participation is to attract partners' involvement. So these are 2 big categories we designed. The first category is to stay on the topic. So basically we can tell a joke to stay on the topic. So here topic specifically means what the conversation topic is. For example, sports is a topic. Usually when we start a conversation with a user, the system would usually start the conversation saying that, hey, I like movies. What do you want to talk about? So movie is a topic that we're here saying. So here we're saying we can tell a joke related to the topic to keep user in the conversation, or we can initiate something activities to do together with the user to keep the user in the conversation. For example, if we want to keep on the sports, we're going to say, do you want to see a game together sometime? Or we can simply just say, let's talk more about sports, just like what the user did in the human-human conversation, saying, can you tell me more about Welsh cooking? Or if you want to change the conversation topic, you can simply just switch, say, how about we talk about movies, so that we're changing from sports to movies. Or you can end this conversation and ask the user to take over to initiate something new. For example, saying, that's interesting, could you share with me some interesting news on the internet? Or you can refer back to the previously engaged topic, which means that we would always remember what the user is engaged about. For example, we talked about sports before, so that we remember that whether he likes it or not. So at this point, for example, we remember that the user likes movies. So we can go back to the movie, basically saying, you said you liked movies before. Do you want to talk more about that? So this is this is two big categories to help you to stay or change the conversational topics, but still helping the user to attract users' involvement. So basically, we put these conversations into a conversational system and ask the user to talk to the conversational system to see how it works. So we used it as, we first tested it out in a wizard or rod setting, which means that we're not doing anything wizard or rod. Basically, we're not involving any human in the conversation, in the system, but only when the user, but we did involve the user in deciding whether the user is engaged or not, to eliminate the errors that the engagement detector may involve. So here, the policy, we basically use a very simple policy. We randomly select one strategy that we design whenever we find the user is not engaged. So here we can see some of the conversational strategies are doing pretty well, some of them are not. So the green bar means that after executing the strategy, the user become more engaged. The red one means that after executing the strategy, the user's engagement level didn't change, while the blue one means that user gets even less engaged. So the goal is basically we wanted to make the blue, green bar much higher than the other two colors. So here we find that the refer back is actually doing pretty well. So the refer back strategy basically is refer back to the previously user engaged conversational topic, is helping a lot. It's actually gaining over 70% of being able to help the user get back to the task. While the others are not doing pretty well. For example, like joke or initiation. So basically, we know later we're going to talk about how we're going to improve them. So basically, the hint is here, if we just randomly select the joke without considering the previous conversation history, basically the joke might be really out of context. So this is not really helping the user to get being more engaged. The second conversational strategy category is called grounding strategies. So here we're going to utilize certain knowledge base, like a Google knowledge base and a Wikipedia, to help us to understand the user better, so that we can be on the same page, so the user actually would be more engaged and thinking we're intelligent. So the first one we got is ground down named entity. So how we're going to do ground down named entity is here. For example, you say, do you like Clinton? We can detect a named entity, which is Clinton. So named entity here means just are the specific, for example, like people name, city name, all these bigger capital letter based terms. So we can detect their named entity here, Clinton, and we can go through a knowledge base and to see all the items that refer to an explanation of Clinton. So basically, you can see that Bill Clinton and Hillary Clinton are both very popular in this. While for the first time when user asks about Clinton, we don't really know who is the Clinton that we're referring about. So what we can do is we can borrow a statistic template to ground down which Clinton you're talking about in an explicit way. For example, TikTok here is the system. You can say, are you talking about Bill Clinton, the 43rd President of the United States, or Hillary Clinton, the Secretary of the State? So after the user tell you, for example, it says Hillary Clinton, then we're able to understand that whenever, most likely if he says Clinton again, which here means what the user really means is Hillary Clinton. So the next time when we're doing the encoding of the sentence, whenever he mentions Clinton, we can add the Hillary inside of the sentence. So here we can basically is trying to combine the logical form of the understanding and the neural network form of understanding together to generate a more appropriate sentences. The second one is ground on other vocabulary words. So a lot of times that we see the words that we have never seen in the corpus. For example, if you said you're very confrontational TikTok. So confrontational is a word that is not in our dictionary, and we don't know what does that mean. So what we can do is that we can use a template to explicitly ask him to explain that. For example, he said, "What do you mean by confrontational?" So the user would basically explain the confrontational in a way that he understands it. So next time when we see confrontational, we can add in the user's explanation in the encoding to help the response generation. The final one is a very practical engineering problem that we see that a lot of times the user would use all these very irregular sentences or typing or in spoken language to ask user to test the system. So basically, what we're going to do is trying to help the user to understand that we are an intelligent entity and you want it to talk in a normal way. So we can very ironically say, can you say something in a complete sentence? So whenever to tag a single word that is in an irregular form, we can ask the user to say in a more complete sentence. The third category of strategies that we're trying to we designed is called personalized strategy. So these are the strategies that we use for adaptation. So whenever throughout the conversation, when the conversation is going, we're dynamically building a personal knowledge base for this particular user about his personal opinions. We would automatically extract these personal opinions. Basically, we're extracting these polarized opinions, basically that has sentiments. For example, like this, the user asked about, do you have any suggestions for movies? So because we have a personal knowledge base extracted along the conversation, we know that the user said previously saying that his favorite type of movie is superhero. Then we know we could go into this knowledge base and retrieve that information and add that in encoding so that the superhero movie suggestion would actually be pumped up in the generation. So for example, we could say that, how about Captain America 2? Another thing that that it would help is being able to remember what the user previously say could really help us to find these non-repeatable things. For example, the user usually wanted to test the system by asking the same question over and over again, just to see if we are being consistent or coherent. So here, for example, the user would say, "What is your favorite movie?" multiple times. If we remember that, we could already point out to the user that you already asked that question before. So finally, we're going to test out all the strategies that we designed for personalization and understanding. So here the green bar means appropriate, which is a good thing. Basically, we saying that the user think their system generated utterance is actually appropriate, and the interpretable, which means that it's okay but not good enough, and the blue one is inappropriate, which means that not coherent. So the goal is basically to increase the green bar for as much as we can. So we do find that, for example, personal suggestion, no repeat actually, and ground on single word is actually really helpful, because the people, for example, ground on single word means that single irregular words. So basically, the user think the system can caught on that the user is actually playing with it, is actually very coherent. And a personal suggestion, which means the user is the user thinks that the suggestion that is personalized is very appropriate most of the time. Plus, there are a little bit of errors that we find, like, for example, in ground and outer vocabulary words, the second line, second bar, which means that sometimes we didn't really consider some of the typos or popular internet words. So we would still ask the user, for example, what does that mean with the typo? And then the user would say, I think that it's a simple typo you should be able to recognize, but you didn't. So they think it's not that appropriate. So finally, we say that after we are being able to create all these conversational strategies to help the user to get back to the conversation, to be more engaged, the second step is saying that what we could do to organize these strategies so that it's coherent throughout the conversation. Let's look at the previous failure in the first strategy category, which is the active participation category. So here the system say, hello, I really like politics. Let's talk about politics. And user said, no, I don't like politics. And system said, why is that? User said, I just don't like politics. So at this point, the system detected the user is not engaged at this point. So it randomly selects their strategy that is in the politics domain. Says, well, how about we watch a debate together someday? And you say, I told you I don't want to talk about politics. So we find that the user is still, after we are proposing this strategy. So what happened here is that the strategy that was selected is not very appropriate inside of this context. So if we look closely, we find that there is some user sentiment that cannot be ignored in the conversational context. We find that the user is expressing negative sentiment towards that topic in a sequence. So what usually appropriate if a human selects it would be a switch topic strategy. For example, okay, how about we talk about movies? And then if we really executed that with the user, we do find that the user feels that is more appropriate. So he's actually said, sure, I do watch movies a lot, and become engaged. So the takeaway message is basically, we should consider conversational history in these conversational strategies, these action planning. So what we're going to do is basically introduce our method to help this. We're going to use reinforcement learning to reach this goal. Basically, we're going to make sure that we optimize towards the long-term effectiveness and naturalness, considering the situation, which is the conversational history. So the key learning is one type of methods for reinforcement learning here, which is the easiest way to explain. So we're going to just explain how we're going to use key learning to help this. And so in key learning, the most important part is the state and action space and the reward. So the state variable, which means that the things that we incorporate, so basically the things we want to track throughout the history. Here we simply introduce several of the variables that we think are important. For example, whether the user is engaged at this point, whether the system utterance is actually appropriate at this time. Basically, the response generated by the previous two generation methods, the keyword methods, or the neural network models. And then all previous utterance sentiment confidence, basically whether the user is actually expressing positive or negative emotions along the way throughout the whole conversation. Time of each strategy executed, so basically each conversational strategy, how many times they executed. So we can see that if certain strategy has been executing for many times, it would be really bad to do that again because users might find it very tedious. Term position, whether we are at the first several terms or at the middle of several terms. So we know, for example, switch topics strategy doesn't really happen in the first two terms. Most recently used strategy. So basically, according to conversational theories, that we understand that if we use the same strategy in consecutive way, people find that it's really robotic. Then the conversational actions, basically these are action spaces for the key learning. So these action spaces are all the conversational strategies we designed so far, the grounding strategy, the personalized strategy, the active participation strategy, and the generated utterances. So basically the utterance that's generated by keyword retrieval or the neural network model. So what we want to know is basically, given these states, we want to know which action to select at a certain time. So here, we basically want to know the reward function is basically something that's driving the planning of the whole conversation. So what are the rewards? So basically, we're saying that if the system is doing something good, we want to give them a positive reward to encourage the system to train towards this. So what are considered to be positive? What are considered to be a good social conversational system? So here we used 4 aspects of conversation. The first of all, appropriateness, basically what we said before, whether the system's response is coherent with the user's utterance locally, or in the previous user's tone. Second, this conversational depth. So basically, are the conversation actually going through a certain depth, for example, following a certain topic. Here we use the maximum number of consecutive utterance on the same topic. So for example, exceeding 9 turns of conversation, 9 turns of utterance that are on the same topic, we think it's a deep conversation. Information gain, basically the unique tokens of conversation. Basically, the more different words that you're contributing, the better we think the conversation quality is. And overall user engagement. So here, the overall assessment of users' engagement in entire interaction, we simply just characterize it as how many turns the user is able to continue in the conversation. Basically, the better the system is, the more you want to continue in the conversation. So during the training of our system, we can't really ask the user to stop and ask all these questions for each turn, which would break the entire conversational flow. So what we're going to do is actually do a reverse reinforcement learning. So we basically pre-train these predictors for each of these aspects of conversation. So for example, we collected a lot of conversations, asked the user to rate how appropriate each conversational response is. And then we train a predictor of all these question pairs. Then basically, we're going to use that predictor score as the during the training. Before we actually train the system with actual users, which takes a lot of human effort, we would use a simulated user, which is another chatbot called Alice, to help us to expedite the whole training process. So here are some results. So here, the blue bar means if we randomly select a conversation strategy, what would happen whenever we detect the user is disengaged? While the red one means that if we only consider like 3 previous turns into consideration in the planning, what would happen? While the green bar means that if we use all the history, what would happen? So we do find that if we use a nice planning strategy in it, we would reduce incoherent rate of the conversational responses, would increase the conversational depth for a lot of. And finally, we got also some gains over the how much unique information that we are providing. We also have other metrics to evaluate these systems. So the blue lines are things that we used for the first time. We didn't use these or any of the policies. While the red bar means that we had all the engagement prediction, the engagement conversational strategy, and the policy, which is what we call engagement coordination, the system that has engagement coordination with the user. So we do find that if we ask the expert to rate out how engaged the conversation is, the red one does basically with our engagement coordination is much better than the baseline. We also counted the number of conversational exchange the user can perform with our system. So basically, the longer, the more turns that they can exchange, they could contribute, the better the system is. We do find the red one almost doubled the blue one in this. So if we summarize up some of the take-home messages, that the active participation strategy is basically helping to improve the user engagement, to deal with the better be interesting complaint that we listed out at first. The grounding strategy is basically to help the open domain language understanding to deal with the better understanding the problem. The personalized strategy is to help us to adapt to different users, so to deal with better remembering skills. So we could add more conversational strategies to deal with different complaints of the user. Finally, we were saying that the statistical policy, the reinforcement learning policy, is to enable the long-term being able to control the coherent and providing variety overall through the reward function design. So now we're going to take a break to introduce other applications that are more task-oriented, or we're going to extend the previous platform to other things. So engagement predictor, it is very generalizable to different tasks because we didn't really use a lexical or semantic meaning. So we could use the previously trained model as a cold start and retrain the model with more adaptive features. We could transfer strategies like grounding strategies and personalized strategies for different tasks because these are basic conversational strategies that are universal for all tasks. So here we're going to introduce one of the applications that we built for a task, which is called targeted movie promotion. Basically, the goal of the system is to elicit a user's opinion about movies and then promote a movie that based on their preferences. They basically wanted to be more to promote a movie that the user really likes. The method that we're using in the system is that we're going to interleave social content with the task content in the conversation, so that it's actually a mixed conversational system. So we could basically, the idea is to use the social information system to elicit the information of the user, to handle the utterances that user is really going out of the domain, and the task information, task-oriented system here is trying to really complete the goal. So basically, we're using reinforcement learning based on the reward to select which subsystems response we're choosing at a certain time. We could use either the social system response or the task response. So the task component here is actually a list of a traditional slot-based system, basically going through eliciting information of the user and then going to the movie type. So the final goal is to let the system to promote a certain movie to the user. Here is an example. Here we say, user say, I like watching movies too, and the system chooses the task-oriented system response saying, do you like superhero movies or Disney movies? And you say, I like superhero movies. And the system could still keep on the task saying, my superhero is Captain America, trying to elicit the user's favorite superhero movie. And then the user say, I like Spider-Man. And at this point, we don't have anything that is that the restricted task-oriented system has that is semantically coherent with Spider-Man. So he used the social response that generated that is considered to be coherent throughout the conversation according to the reinforcement learning. Asking, do you watch them with your kids? And you say, I don't have any children. And at this point, where the user is actually trying a little bit out of the control of the conversation about movie. So the social system really takes it over and to correct this conversational topic diverse. Saying, what I meant to say was, what is that you hate? So now we're back to the movie about likes and hates of the movie. And you say, I hated the last Fantastic Four movie. And the system can't really talk about Fantastic Four movie here to ground out which fantastic movie they're talking about. For example, are you talking about Fantastic Four, the 2005 movie? And you're going to say, yes, I am. Now we're going to really talk about the task again to talk about the first Avenger movie that we might promote to the user. So the basic idea here, we're saying that we could use a social system that interleaves the task system to help the user to get to stay in the conversation, to complete the task in the end. So here we basically tested out the base system, which doesn't have a social component, and which is the blue line, and the red line, red bar, which is the one that has the social system that has the engagement coordination. we do find this users find it more engaging. And the task success rate, basically whether the user gets promoted a movie in the end, basically more people stay to the end of the task and get the promoted movie compared to the baseline. One interesting finding is that we did collected all the information about different users, and throughout the 100 conversations, we do find that many in their 20s like superhero movies the most in the US, which is very correlates with the surveys that the American Movie Academic conducted. So we say that this type of conversational system is not merely for this particular goal about promoting targeted movies. It could be expanded for other things. For example, recommending music, recommending recommending products, or even collecting surveys about like political surveys or anything that is related to that has something that the user is flexible in terms of it doesn't really know what he wants to do. Another application we have is called education application that we did. So basically, it's an adapted interview training. So the system is basically act as an interviewer, and the user is the interviewee. And we are trying to interview the user for a job. So the goal is actually not really to assess the interviewee's ability of being a good candidate. It is trying to help the user to improve their second language learning ability. So we wanted to help the user to communicate better, which is a very important aspect of language learning. So we basically tested it out with different people. Here we did everything on Mechanical Turk. We recruited different users through Mechanical Turk. It's a collaboration with ETS. So here is an example of how the system works. Too bad. Sorry, I need to change back to my screen on this. So here is video. It's actually awesome. Either it's not age. Basically, what we're gonna do is being able to use certain conversational strategies like encouragement and positive feedback to make sure the user is engaged in the conversation and could continue in this conversation to help him to train his language ability. Sorry.
If you had a disagreement with a coworker, would you prefer to settle the matter directly with your coworker, or would you report the incident to your manager?
I'd talk to the coworker so he knows what he's doing and he doesn't get in real trouble. Well, maybe if he does something really, really bad, then maybe yes, I'll report him to the manager.
Think the manager would do next?
Cut his pay a little bit.
So at this time, we are able to detect that the user is not engaged by averted gaze, short answer.
I don't really know, actually.
Yes, I think a lot of managers would do that.
So basically, we give him an encouragement saying that we think the manager would do that. You should continue being positive about the user's response. Okay. So finally, we're going to talk a little bit about like attention. So attention is another concept that along with engagement, which is very important to conversations in general. Attention, we just categorize as the visual focus of the user. For example, here it's a robot that sits in the corridor. It's trying to give directions to different people. Here we see that actually in real interactions, we would have problems in different occasions. One of the problems that we see that is the user is not being, the system is not being able to detect user's attention that creates this problem.
You need say that again.
Looking for my meeting.
Right.
Well, give me a minute.
Sorry, Eli, you wanted. Correct.
The problem that we see here is basically the user is trying to look at her phone saying, give me a minute, while the system is not being able to accommodate that and not knowing that the user's attention is not on him at this moment, and try to do speech recognition for different errors.
Right.
So what we're going to do is basically we see that we look into the human conversations to see what do humans do to attract users' attention, to accommodate users, to attract users' attention so that we could perform. So we do find that this is a lot in real human conversations to attract users' attention. For example, here, the red dotted line means that Brian is not looking at Barbara. You're gonna have your kids have to go. Kind of a disfluency changes. The listener really goes back to the Barbara at this point. So we can see that all the time. So these disfluencies actually really attracts users' attention. So we basically say that we're going to put this inside of the robot as well to attract users' attention. And how are we going to plan this? So basically,
Zhou, can you hear us?
This is early.
Okay, we can hear you.
Sorry, when did it end, really? Okay, where did you miss from the...
From the video with the robot and wait a minute and something like this.
Let's see. Sorry, I don't know why this is the demo video of the robot.
After the demo, when you have explained about these conversation for wait a minute and stuff like that.
Oh, I see. So, did you see their example video of their robot?
Yes.
Here?
Yes.
Okay, so that's, you only missed like a minute. Okay.
Okay. Yeah.
Sure. So finally, I'm just gonna summarize it and take questions. I think I'm a little bit out of time.
Can you share your screen now?
Yeah, sure. Go over to the share.
Okay.
Can you see the slide?
Yeah, great.
Okay, great. So basically, I'm just going to summarize and take questions. So overall, what we're saying from this lecture is multimodal information is really useful for interaction planning. And using computational methods like natural language processing and knowledge base could encode conversational theories to facilitate interactions. Finally, reinforcement learning is basically something that we could leverage to make a long-term optimized interaction planning. Situation intelligence framework is applicable in various domains like education and entertainment, and it is really augmentable on different existing systems. So you don't have to build a system from scratch, and you can just add the different components in it to improve the functionality of the system. Okay, so I can take questions now. Let's see.
Great. Actually, we are almost started the next talk. And so I think that if it's possible, can you answer the most pressing question for all the participants, which is, what do you think is the best way to evaluate dialogue systems? What should be your strategy to do this?
So dialogue evaluations, system evaluation has different ways of doing this. So we have different metrics for different kinds of systems. So I would say that usually the two types of things that we usually talk about systems are task-oriented and non-task-oriented. The task-oriented system, the best way to evaluate them is for sure to have them to interact with a real user with real needs. So if then basically whether the user is able to complete the task, basically task completion rate is one metric that we look at a lot of times. And also other things that we think are very important are the user's feedback. Did they want to interact with the system again or not? Did they find that it's easy to interact with the system? So all these feedback about the user's preferences are also important besides task success rate. So that's why I think a lot of other people think as well that only by evaluating the system with the people who have the real need of using the system would be the best way to do this. For sure, a lot of times that we say that we can only sample certain users. It's not the complete group of the user you want to do, but it's still the best way of doing it. While other things like a non-task-oriented system, for what we say is like a social conversational system that doesn't have a task to evaluate on, so we would usually say that a lot of aspects of the system really matters. For example, a coherence that we want to measure, how long the user is able to complete the conversation, how often the user wanted to come back to talk to the system. All these are important metrics for evaluation.
Okay, thank you for your very interesting talk. Sorry that we still have no time for more questions, and maybe we.
It's really fun. If anybody has any more questions, you can always email me. Yeah, you can find me on the website.
Great. And so, also, can you send me a link to your presentation? Is it possible to put it on our webpage?
Oh, you mean the slides?
Yes.
Yes.
Okay, great.
Yes, I could.
Yeah, thank you. So let's thank Zhou. Bye-bye.
Okay, bye. Good luck with the rest of the